Hi, today me and my friends are going to talk about the short and long-term pre-stress losses. We are from group 2 from 7C1. The group mates consists of me, myself, Alia Nabila, followed by Nawal Azrin, Nurul Hanisa, McDarrell, and Nurin Sasabila. This is the overview of what we are going to talk about. There are 6 contents of what we will explain later on. So, firstly, what is pre-stressing? Pre-stressing is technique used to improve the performance of concrete by introducing the internal compressive stresses before it carries any external load. Since the concrete is strong in compression but weak in tension, the pre-stressing helps to counteract the tensile stresses that occur under the service load. This is achieved by tensioning the high-strength steel tendons or cables within the concrete, either before the casting or after hardening. For an example, before the beam carries any external load, the tendons are stretched and anchored, causing the concrete to compress. And when the beam later carries the loads, these compressive stresses offset the tension, and it will reducing the cracks and deflection. Next is, what is pre-stress losses? Pre-stress losses is refer to the reduction in the effective pre-stressing force in the tendons over time, and after the pre-stressing, the initial force will gradually decreases to an effective forces, which due to the several factors. Moving on to the causes of pre-stress losses. So firstly, it will happen when the elastic shortening of concrete in an instant loss. Second, it will happen when creep and shrinkage of concrete, which happen on time-dependent losses. Third, relaxation of steel tendons. And the fourth is the friction and anchorage slip, mainly happen in the post-tension members. Next, why it is important to understand the pre-stress losses. It is because the effective pre-stress determines how well the structures resist the tension and cracking. It is also accurate estimation ensure the serviceability, durability, and safety of the pre-stress structure. If the losses are not properly accounted, the beam may lose the strength and the stiffness, and it will also experience the cracking and increase in deflection or reduce in the service life. To summarize what is the pre-stressing and the pre-stress losses, we could see that the pre-stressing is happen when we apply the compression before the loading, while the pre-stress losses happen when the decreasing in tendon force over the time. And we need to understand that the losses is vital for serviceability, crack control, and the long-term performance.
The immediate losses due to the elastic shortening. So we have two, is the pre-tension concrete and post-tension concrete. Pre-tension concrete is that the both concrete and steel are shortened, which is we get the result in the pre-stress loss. And then for the post-tension concrete, which is if the cables are tensioned simultaneously, so there is no loss occurs. So if done sequentially, and each tendon loses pre-stress due to the shortening of the previous tendons. So basically, the loss is to quantify by the drop in the pre-stress from the change in the tendon strength, also equal to the strain in the concrete, and the tendon level due to the pre-stress force. So next is the formula that we'll be using to find the immediate losses due to the elastic shortening. Second one is the immediate losses due to the friction. So basically, when a post-tensioning cable is stressed, it moves relatively to the duct, and the friction resists this movement. So as the result, the effective pre-stress force decrease at the position farther from the checking point. So we have divided by 2, unintentionally profile variation and also design variation of the duct. This is the Woburn effect, which is we will be usually used in the straight ducts. And next is the duct curvature, which is caused the greater pre-stress losses. Lastly, we have the immediate losses due to the occurrence slip. So basically, the slip of wire through the anchorage causes a release of the some prestress. So the amount of the slip depends on the type of the wedges and the straight release in wire. So how we calculate, which is the loss of the strength result from the shortening of the tendon, and then we calculate the percentage loss which is greater from the shorter member, and then reverse the friction develop as the anchorage block set and the tendon shorten. So this is the how we calculate the loss of the prestress due to the slip, which is P/8 equal to modulus of elasticity of the steel and divided by length of the cable.
Due to concrete grip, which is the time-dependent increase of deformation under sustained load, where due to grip, the prestress tendon is decreased with time, and the factor that affecting grip and shrinkage of concrete is age, applied stress level, density of concrete, cement content, water-cement ratio, relative humidity, and temperature. Next, creep is due to sustain permanent load only, where temporary load are not considered in calculation of creep. Since the prestress may vary along the length of the member, an average value of the prestress is considered, where prestress change due to creep, which is related to the instantaneous prestress, where we must have to consider this interaction, and the calculation of creep can be iterated over a small step, where we can consider stress in the concrete at the level of the steel, where A is the area of beam and I is a moment of inertia. And law of steel stress, ES, is a modulus elasticity of steel, and average stress and also multiplied by specific creep strain. The value of specific creep are influenced by several factors that I already stated and obtained by using creep coefficient. This version is a creep coefficient from Eurocode 2. Next, time-dependent loss due to shrinkage of concrete, where time-dependent strain measured in an unloaded and unrestrained specimen at constant temperature. The factor that contributing to creep of concrete will have influence on shrinkage of concrete also, accepting the loading condition. Due to shrinkage of concrete, based on empirical figure for shrinkage unit length of concrete for particular curing condition at transfer maturity. Shrinkage strength to be considered depend upon the following factors such as aggregate use, original water content, effective edge at transfer, effective section thickness, and ambient relative humidity. There are several steps to calculate time dependent due to shrinkage of concrete, where the pre-tension stress at 3 to 5 days and the loss in steel stress is given by shrinkage strain and modulus elasticity of steel. Hence, loss in pre-stress force is shrinkage strain, modulus elasticity of steel, and area of tendon. Last one is time-dependent loss due to state realization, where realization is the reduction in stress with time at constant strain. It is decrease in the stress is due to the fact that some of the initial elastic strain is transformed into inelastic strain under constant strain. Stress decrease according to the remaining elastic strain. That factor that affecting to realization is time, initial stress, temperature, and type of steel. Loss due to realization of steel is usually about 70% of the characteristic strength, and the losses is about 4 until 10% of pre-stress force after the transfer. Table 4.3 shows the realization factor for a steel where it is whether pre-tensioning or post-tensioning, and it involves for class 1, class 2, and also class 3.
There are many effects of pre-stress losses. Firstly, is the reduction of effective pre-stress. Pre-stress losses decrease actual effective pre-stress force, thus reducing compressive stress. This results in lower efficiency of pre-stress force. Secondly, structure will be more prone to deflection and cracking. This is because the compressive force failed to counteract tensile force, forming cracks and deflection under service load. Thirdly is reduced serviceability. Long-term deformation due to creep and shrinkage reduces the service life of the structure. Eurocode 2 accounts for pre-stress losses by reducing the jacking force to obtain the effective pre-stress used in design. Clause 5.10 defines this as the initial force minus all immediate and time-dependent losses. Losses arise from friction index, anchorage slip, elastic shortening, steel relaxation, concrete shrinkage, and creep. Friction and anchorage typically reduce the force by 3 to 10%, elastic shortening 2 to 8%, relaxation 1 to 8%, creep 5 to 10%, and shrinkage from 3 to 8%. Altogether, the total loss is usually 15 to 25% for pre-tension members, 10 to 20% for bonded post-tensioning, and up to 30% for unbonded tendons. Hence, Eurocode 2 designs generally assume an effective pre-stress of about 70 to 80% of the original jacking force.
Conclusion. So, for minimizing pre-stress losses, first we need to remember that in practice, the total pre-stress loss can reach up to about 30% of the initial forces. This means that if we apply an initial pre-stress of, for example, 1000 kilonewtons, only around 700 kilonewtons might remain effective after all the short-term and long-term losses occur. So that's why controlling these losses is very important to maintain the required stress in the structure. So there are several practical methods that we can use to reduce pre-stress losses. So the first one is we have to ensure that we use accurate jacking and anchorage. So hydraulic jacks should be correctly calibrated and anchorages must be well positioned to avoid slip and ensure the correct pre-stress force is transferred. And then the second one, you have to use smooth and aligned dock to reduce friction losses during tensioning, for example in post-tension members. Next one is we have to ensure correct stressing sequence. For example, in multi-strand beam, pre-stressing should be applied in proper sequence to minimize elastic shortening loss and achieve uniform stress distribution. The next one, we have to use proper curing and high quality concrete with low water cement ratio, which help to reduce shrinkage and creep, which are the main sources of long-term loss. And the last one, I advise to use low relaxation steel, which low relaxation steel help to maintain their stress level over time, which can reduce long-term losses that caused by relaxation of steel. So, in conclusion, pre-stress losses are divided into two, which is short-term and long-term, which are both are unavoidable, but they can be predicted and controlled through good design and construction practices. By understanding the causes of losses, engineers can ensure that the effective pre-stress remains sufficient to prevent cracking, reduce deflection, and improve the service life of pre-stressed concrete structures. Therefore, careful attention to material quality, tensioning methods, and site procedures is essential for achieving durable and reliable pre-stressed structures. So that's all from us. Thank you.